Good day. So in this video, we're going to be looking at exponential graphs. So without wasting any more time, let's dive straight into it. So firstly, we're going to start with analyzing the general equation of exponential graph. So the general equation is y is equal to a to the power of x minus p plus q, right? So let me just basically explain what each variable does to the graph, right? So Q is what we call a vertical shift. Vertical shift. So what it does is it basically shifts the graph up and down, right? Whereas P right here, it basically is what we call a horizontal shift. So it will obviously shift your graph left and right. But P is not one value that we're going to have very emphasis in or analyze the most. The value that I really want us to focus on, or the two values that I want us to focus on, is obviously our vertical shift, where there's nothing really much into it. We're just going to insert a value, and that value will shift the graph up and down. So how it shifts the graph up and down, it also makes the graph basically our horizontal asymptote. Horizontal asymptote. So this value of q will also be the same value where the graph can't touch. So at this point, the graph can't basically touch that point. That's what an asymptote is. So the biggest value that I want us to focus on is obviously a. A is basically what shapes our graph. So it shapes our graph, right? So let's see how it shapes our graph. So I have four graphs here, and I'm going to tell you the impact of A by basically explaining what it does to in different cases. So if our A is greater than 0, if A is obviously greater than 0, or A is basically greater than 1, let's put it like that. How our graph will look like, it will look something like this. Let me just use a different color. It will look something like this. So it will be an increasing graph. So for each value of x that we add, our y value will also increase, right? Our y-intercept will most likely be the same. Our y-intercept will most likely be the same in many cases, because we know that a to the power of 0 is equals to 1, or any value to the power of 0 is equals to 1, so long that value is not 0, right? So our y-intercept in many cases will always be equal to 1, right? So with the next one, we have a, and then if a is less than 1 but a is greater than 0, so in this case a will basically be a fraction, right? A can be any fraction. A can be 1 over 2 to the power of x in that matter. So just know that your a is positive but is less than 1, right? So in that case, your graph will basically be a decreasing function. So it would look something like this. It would look something like that. So for each value of x that you add into the graph, obviously your graph will increase, right? So if I add 2 to x, to this x right here, I know that this 2 will obviously make the graph, or the final value will be 1 over 4. So 1 over 4 is obviously less. If I add 3, it will be 1 over 8, and so on, so on. So the graph basically becomes less for each value of x that increases with this graph right here, or with this, or if a is less than 1 and greater than 0, right? So what if a is basically less than 0? So now a is a positive. It is less than 0, but it's not a fraction. So in that situation, that's when you start seeing the graph going down like this. Going down like this. So obviously, if a is less than 0, the value of a will be negative. So let's say, for example, we have negative 2 to the power of x. We have a graph which says y is equals to negative 2 over x, to the power of x, sorry. So in that case, whatever value of x we're going to add, our y value will always be negative. So the more we add x, or the greater x becomes, your y value becomes less. So for example, I know negative 2 to the power of 1 will be equal to negative 2. Negative 2 to the power of 2 will become negative 4. So basically your graph is basically decreasing at all times, right? So that's what the impact of a has on a graph that has a negative a value, basically. So the last one says if a is is greater than negative 1 but is less than 0. So in this case, a is a negative fraction. Is a negative fraction. So in that case, it would be negative half to the power of x. Negative half to the power of x in that for that matter. So what happens when our graph is like that? So let's analyze what the impact of x will have on the graph, right? So if I say, let's say x is 2, so now I know that negative 1 over that to the power of 2, that will give me negative 1 over 4, right? But what if my x is a negative value? So now if my x is a negative value, I know that, let's say it was negative 2. What happens is this negative 2, in order to get rid of the negative, we have to switch the fraction. So we have to say 2 over 1. So now our negative becomes a positive. So that will give us the value of 4, since 2 to the power of 2 is 4. So you see now with this function that we're going to draw, basically the graph is increasing with each value of x that we add. It's increasing with each value of x that we have. If x is more or negative, our graph is basically less in a way. Sorry, this will be negative here. Our graph always becomes less. So those are the 4 types of exponential graphs that you're basically going to find. So I just wanted us to analyze the value of a more, so you see the type of impact that it has on the graph. So now let's start analyzing the value of q. So now we're going to start analyzing the value of q. As we've already mentioned, q is our vertical shift, which also is our horizontal asymptote. So in other ways, if you look at all the graphs that we've drawn here, we've always assumed that the value of q is 0, right? In all these graphs, across all these graphs, we've always assumed that the value of q is 0. So in every graph that we drew, all these 4 graphs, you can analyze that the graph never touches the x-axis. It never touches that point, the x-axis, right? So it's because we assume that the value of q is 0, and when the value of q is 0, our x-axis is basically our horizontal asymptote. So the graph will progress close to that x-axis, but it will never touch that point, right? But what if our q changes? What if our q now becomes 1? What happens to our graph? So when q becomes 1, it basically shifts our graph. Now our graph will basically increase in size, or it will basically go up. So in this case, if q is equals to 1, now we're gonna have an asymptote here at 1, and our graph will basically shift up. It will shift up. Now it will never touch the value of 1. Right? It will never touch the value of 1. So that's what basically q does. What if in this situation our q is equals to negative 1, right? So now we know that our graph will obviously have an asymptote here at negative 1. Our graph will have an asymptote there at negative 1. So basically what our graph will do is it will obviously shift down. It will shift down and intersect wherever it intersects. I'm sorry, it might not intersect at that point. I'm just trying to show an example of a shift. It might not intersect at that point. I'm just trying to show an example of a shift. So now our graph basically goes down and never touches that point at negative 1. So basically q shifts our graph up and down, right? So yeah. Okay, so now we're going to talk about our horizontal shift, right? We're going to talk about our horizontal shift. Remember our general equation to an exponential function, we said it's a to the power of x minus p plus q, right? And we said our p is basically our horizontal shift. It's our horizontal shift, right? So what do we mean, right? So we're giving an example. We said f of x is equals to 2 to the power of x, right? So we're going to try to draw that graph. So here we're going to put x as 1, obviously x is 2, 3, 4, so on and so on, right? So we know that when x is 1, y will obviously be 2. Y will obviously be 2. Let me just quickly erase that so I can write it properly. We know that when x is 1, y will be 2. So we're going to have that point right there, right? So when x is 2, y will obviously be 4. So our point will be somewhere here. When y is 3, our graph will obviously, or our y value will obviously be 8. So that will be somewhere around here, somewhere around there, right? So when we draw a graph, we know that when y is 0, our graph will be 1. So it will be somewhere around there. So that's where our graph will intercept, obviously. So we're going to draw a graph will intercept somewhere there, going all the way up, and it increases exponentially, right? So you can see that it's increasing exponentially. If y is 4, if x is 4, our graph will be 16, so on and so on. So it increases exponentially. That's why they call it an exponential graph. So what happens now if we change our equation? So now we're going to say f of x plus 2. So now our equation is no longer 2 to the power of x, it's 2 to the power of x plus 2. That's why the plus 2 is there. So now it's x to the it's 2 to the power of x plus 2, right? So let's see what that 2 does. For each value, if y was or x was 1 in our 2 to the power of x graph, y was 1, we know that if x was 1, we know that our y value was 2. Now with this one, when x is 1, we add the 2 there. So x won't be 1, it will be 3, but our y value will stay the same, it will still be 2, right? And if x is obviously 2, our y value is 4. Now x will be 2 plus 2, which is 4, and our y value will obviously be 4. It doesn't change. So our y value doesn't change. Basically what changes is our x value. So that's why this is called a horizontal shift. So let's see how, if we were to plot a graph of 2 to the power of x plus 2, how it would look like, right? So we said when x was no, sorry. Now we know that when x was 1, y was 2, right? So we're going to keep the y value constant, which is 2, obviously. So now we're just going to add plus 2 to the x. So we know that our coordinate now is 3 and 2. 3 and 2. So here we know that when x is 4, our y value is obviously 4 as well. So our graph will basically look something like this. It will look something like this. And then it's going to continue going up. So basically our graph, when we have a positive p value, our graph will shift to the right. And obviously we can assume that when we have a negative p value, our graph will shift to the left. So I'm just going to write that. So if p is greater than 0, our graph will shift to the right. And if p is obviously less than 0, our graph will shift to the left. Will shift to the left. So that's basically the impact of the horizontal shift. It basically shifts the graph left and right, whereas q obviously shifts the graph up and down.